All right, welcome back, Algebra kids. This is our second week, so hopefully last week we were able to understand just kind of the gist of quadratic equations, what they look like, how to find the axis of symmetry, the vertex, is the vertex a maximum or minimum, so all that we learned last week. And this week all we're going to do is find the vertex, and then we're actually going to plot points on each side of that vertex so that we create the accurate parabola. Just a heads up, guys, the topic here, this is chapter 9, lesson 2 in your book, and it's called How to Graph Quadratic Equations. You can find your textbook in mathexcelforschool.com, and you can also find it in Realize Reader, and there will be several examples in there if you need some more help on these. So here are the 4 steps to graphing a quadratic function. First, find the axis of symmetry. We learned how to do that last week. So we do that by our equation, x equals negative b, or opposite of b, over 2a. So let's plug in our values. B is negative 6. So if we want to do the opposite of b, that would be positive 6. Over 2 times our a value, there's nothing in front of the x squared, so there's a 1 there, so 2 times 1. 6 divided by 2 is 3, so our axis of symmetry is x equals 3. So on the graph, if we come over to the x-axis and go to 1, 2, 3, then that vertical line, this is our axis of symmetry where we fold, and the 2 sides of the parabola will lie on top of each other, be equivalent, okay? Next step, here's the axis of symmetry. Next step, we want to find the vertex. Well, we did that last week as well. So we have the x value of our vertex. So remember, the vertex is always an ordered pair. So we have the x is 3, but now we need to find what's the y value. So take, again, your original quadratic equation and plug in x is 3. So y equals 3 squared minus 6 times 3 plus 11. So 3 squared is 9. 9 minus 6 times 3, 18, plus 11. So we've got negative 9 plus 11. So y is 2. So our vertex is 3, 2. All right, so if we come over here, 1, 2, 3, up 2, here is our vertex. Now, we do know that this is going to be an upward parabola because the a value is positive. So we know that the vertex, this point that we just plotted, that is the minimum, because the graph's never going to go below that point since we know it's an upward parabola. So put the vertex, next step, in the middle of, or the middle row of your table. So what that means is you're going to create an XY table. Right in the middle of this graph, you're going to put your vertex. The reason for that is because the points on the 2 sides, so if we want to see when x is 2, all right, and we plug that in, well, it's going to be the exact same when x is 4, and we'll do that example, simply because we know that axis of symmetry over here, they're equivalent. They're going to fold, they're going to be the same. So let's plug in 2, so we'd have 2 squared minus 6 times 2 plus 11. And all I did, guys, to get that 2 is I just picked one value smaller than the x equals 3, our axis of symmetry. So 2 squared is 4, 4 minus 6 times 2, 12 plus 11, 4 minus 12, negative 8 plus 11 is 3. So 2, 3 is a point. So 2, 3. All right, I'm going to erase that point. I was just showing that's where I was going next. So then the other point 4, let's plug that in. So 4 squared minus 6 times 4 plus 11, just plugging 4 in for x. 16 minus 24 plus 11. We've got negative 8 plus 11 again, which is 3. So it does work out because, like I said, over that dotted line, it should be a mirror image. So we have that one plotted. Okay, it does help to plot at least 2 more points. Again, they should have the same y value. So I'm going to go one smaller and one bigger. Again, hopefully these are the same. So let's see. We would have, I'm running into the next question, 1 squared. I'm going to do that in my head because that one's easy. 1 times 1. Minus 6 times 1, so minus 6. Plus 11, so negative 5. Plus 11 is 6. So 1, 1, 2, 3, 4, 5, 6. Here's our next point. And then we'll do 5. So 5 squared is 25. I'm starting to do some of this in my head. Minus 6 times 5 is 30. Plus 11, negative 5, plus 11 is 6 again. So we'll go 1, 2, 3, 4, 5 on the x. 1, 2, 3, 4, 5, 6. Again, notice they're mirror images. Okay. Once you get, if I did 0, I'm pretty sure it would fall off the graph because they increase pretty quickly. 0, yep, it'd be 0, 11, and I wouldn't be able to fit that. So it is smart to choose points that are right on the 2 sides of your vertex point. Okay, so here is our parabola. Here, I can't draw, is my vertex, and that is what we call a minimum. Okay, there we go. So domain. Remember we talked about domain values are your x values. So everything, where's this graph going to go according to those x values? Well, that is going to always be all real numbers as long as your parabola is upward or downward. Okay. Next one then are range values. So remember, ranges are y values. So let's look at y values. This would be our y-axis. So where is this graph going to be? Well, it's never ever going to go below this vertex point. So our our range is our y values. So y always is going to be greater than or equal to that point. So y is greater than or equal to 2, and you can get that also from your vertex point there. Okay, so there's the first example. I'm going to do a couple more with you because you will have different types of examples on your math Excel homework. So again, first step, find the axis of symmetry. So x equals negative b over 2a. Opposite of b is negative 4. 2 times, in this case, a is negative 2. So negative 4 over negative 4 is positive 1. So our axis of symmetry is x equals 1. So I'll come over to the graph, x equals 1. Remember, these are always vertical lines. Here's our axis of symmetry. Okay. Step 2, up here then, find the vertex. So we're going to take x equals 1, plug it into our equation. So y equals negative 2 times 1 squared plus 4 times 1 plus 1. Be careful if there is an a value. Make sure you do order of operations. So 1 squared first is 1, then times negative 2, plus 4 plus 1. Negative 2 plus 4 is 2. 2 plus 1. So y is 3. So our vertex, we already have our x value is 1. And then we just found out y is 3. And, whoa, sorry guys. We can come over to the graph. 1, 2, 3. Here is our vertex. Now, in this case, the a value is negative, so I know this is going to be a downward parabola, a frown. So this point, that vertex we just plotted, I already know that's my maximum point because of our a value. All right, I know all my points should be below that. If not, then I've done something wrong. Okay. Now, next step, put that vertex right in the middle of your XY table. You want to choose 2 points bigger than the x value, 2 points less than, okay? Your 0 and your 2, these y values should be the same, and then the -1 and the 3, those y values should be the same. So, let's double check. I'm going to, scoot over here. 0 is an easy one to do. Here's for the next problem. Because when we put in 0, everything multiplied is going to be 0. So we're going to get -2 times 0 squared is 0, plus 4 times 0 is 0, plus 1. So y equals 1 when x is 0. There we go. Do the same thing with 2. So let's see, -2 times 2 squared. This should be the same as when x is 0. So 2 squared is 4. 4 times -2 is -8. Plus 4 times 2 is 8. Plus 1. -8 plus 8 is 0. 0 plus 1 is 1. So y is 1. All right, and we can plot those points. So 0, 1, 2, 1. Again, they are mirrored across that axis of symmetry. Okay, let's plug in -1. So -2 times -1 squared plus 4 times -1 plus 1. -1 squared is +1 times -2. We get -2. Positive times a negative, so -4 plus 1, -6 plus 1 is -5. Okay, do the same thing with 3. Oops. And I ran out of room again. Let's see, -2 times 3 squared plus 4 times 3 plus 1. 3 squared is 9 times -2, -18 plus 12 plus 1, -18 plus 12, -6 plus 1 is -5. So again, those are mirror images. We can plot those 2 points, -1, 1, 2, 3, 4, 5 down, and then 3, -5, and then plot your points to create your parabola. Notice this one's a little skinnier. Oops, not the best parabola there. Then the last one, and it's all because of that a value. That a value was multiplying it by 2, so it squeezes it in. It's a little skinnier. Okay, if your a value is a fraction, so let's say 1/4, 1/4, it's going to expand and make the parabola wider. Okay, so I'm just going to do those 2 examples. Oops, I forgot the domain. Same as last one. It's your y values. That parabola is always going to increase both right and left forever. So that would be all your real values. The range, since we know this one is, here's our maximum I have over here, that pink pointing to the maximum point. We know the y values are never ever going to be greater than that point. So y has to be less than or equal to the y point of 3. Okay, so everything below there. All right. Questions with any of this, reach out. Don't hesitate to ask. And then next week, we'll do a short video over finding the solutions to these quadratic equations. And then I'll do a little quiz for you guys next week on all the graphing of quadratic functions. All right. Thanks for listening. Have a great day.